Let us go to workbench, right click solution, click edit. We shall start the run. The solver has started now. Please note that the first solution will fail because when we run such complex cases, that is with vein diffuser and volute, the solver will not converge easily. So we have to run with a lower back pressure so that the flow will be established quickly. After that, we can slowly increase the back pressure to get the converged result. I will show you the results of different back pressure cases and then I will show the final result. Here you can see the converged results for 3 cases. That is the first case with 400 iterations which has run for 1 bar back pressure. The second case is having 2 bar back pressure and the last case is having 3 bar back pressure. If we start the analysis with 3 bar pressure directly, the solver will fail and we will not get a converged solution. Mainly because to establish the flow, the solver needs to run for a stable condition, that is the exit pressure should be low compared to the inlet pressure so that the flow will be first established. After that, slowly we can increase the back pressure to get a converged solution. Here the first portion is the 1 bar case and the second portion, that is still 800 iterations, is the 2 bar case, and only after that you are able to get a converged solution for the design case, that is the 3 bar pressure case. We can see the mass flow and other parameters here in the plot monitor. This is the mass flow parameter for inlet and outlet. We can see both has converged very well. Similarly, the efficiency value and pressure ratio and temperature ratio. Now we shall post-process the results and check the aero parameters and flow parameters. Let us close CFX solver, right click and edit results. We shall right click results and click edit. We shall go to turbo mode first and then initialize the components. R1 and S1 will initialize, but S2 will not initialize because S2 is not a conventional turbo component. We shall choose velocity components here. Coming to outline, we can see the flow pattern. Choose turbo surface. Select Mach number as a variable. Click apply. We can see the flow contour in impeller and diffuser. We shall change the number of blades to maximum value. We can change the render settings in S2 casing. We can increase the transparency to 0.8. Here you can see the flow contour. We shall add streamlines also, starting from the volute entry region, that is S1 to S2 side 2. Side 1 is for volute entry, so we shall choose that and then click apply. We shall change it to side 2. We shall change the range to local range. Here you can see the flow pattern inside the volute. We can see the flow swirling and coming out of the volute. Now let us check the global parameters. Come to expressions, mass in, mass out, pressure ratio, temperature ratio, efficiency. This is the analysis output as compared with the target values. The pressure ratio is 3.05, mass flow is 2.02 kg per second and the efficiency is 78.2%. So it is almost matching with the target values. In this simulation, the main thing is to run the case with lower back pressure and then continue with the higher back pressure. Whenever you are giving with the higher back pressure, automatically the earlier case, that is the lower back pressure case, will be given as the initial condition in Ansys workbench. So it will be easy to solve the case from the given initial condition. We can also give the initial condition manually. Whenever you are solving case, you can go to new and you can go to this initial values, and by default it will be showing us current solution data. We can change it to initial conditions and then load whatever results we need to give us initial values here, so that it will quickly converge and then it will avoid unnecessary time delay. Okay, thanks for watching. I will see you in the next lecture.